Hello, and welcome to AWS Supports You. I'm Gaurav, a technical account manager based out of Delhi, India. We are happy to bring you yet another episode focusing on security. On this show, AWS support experts provide tips to optimize performance in the cloud, lower costs, and share with you best practices and design considerations. Joining me today is Dipanshu from AWS Support. Can you give us a quick introduction, Dipanshu?
Sure. Thank you, Gaurav. Hey everyone, my name is Dipanshu. I am a technical account manager here at AWS, and I am also based out of New Delhi. My experience is on operating system and containers, and that's what we are going to talk today. Back to you, Gaurav.
Thank you, Dipanshu. So today we'll be introducing you to securing EKS clusters using Bottlerocket. We'll be specifically focusing on Bottlerocket and its components while walking you through as to how Bottlerocket helps address the security concerns when it comes to containers. But before we get into the details, a quick note to our attendees online. Please feel free to use the chat window on the right-hand side of your screen to let us know where you are joining us from. Please share your thoughts and questions throughout the episode and keep it interactive. We look forward to hearing from you. We'll also provide you a link to a survey during this episode. So do click on the link and leave us your valuable feedback. So with that, I'll hand it over back to Dipanshu to take us through Bottle Rockets and its features.
Thank you, Gaurav. So I'll first talk about the agenda that we are having today. So I'll start with a customer story, and then we will discuss the current security challenges that we have. I would talk a bit about Bottlerocket, its implementation, and there would be a quick demo as well. I have a dedicated time for question and answers in the end. But as Gaurav said, please feel free to use the chat to type your questions as we proceed with the session. Yeah, so without any further ado, let's start the session. Let me first share a customer story and how they built a satisfactory solution using Bottlerocket. So earlier, the customer that started using Bottlerocket, they were having their EKS cluster and their application hosted on EC2 Linux nodes. And their application was having a very specific requirement where they have to keep the port open, let's say port 1234 open for the whole internet, right? So what happened, the attackers, they identified this loophole, and they gain access to one of their worker node on that open port, and then using that open port, they got access to other nodes as well. Then they got some information from the nodes. The customer was able to identify this unauthorized access to their nodes, so they reach out to us. We were involved proactively, and we were able to control the node and the security of the cluster in no time, and there were really no harm done. But as the customer was having a specific requirement, the application requirement for opening port 1234 for everybody on the internet, so we had to figure out a solution, right? In that scenario, we suggested them using Bottlerocket, because it is designed to be secure and designed to be container optimized. And then we implemented Bottlerocket in their environment. We initially started with one application, and then we rolled out to the entire cluster. And now the customer is very confident to keep that port open publicly. So in the coming slides, we would be understanding how Bottlerocket is helping the customer and making their environment secure, even with a port open publicly. So I'll start with some security challenges, where I will discuss what threats we can have with a general purpose operating system like Linux or Amazon Linux 2 in our case, right? So in Kubernetes, the containers, they are hosted on a server. When I say server, I mean some operating system. And that server can be of Linux, can be of Windows, It can be serverless like Lambda or Fargate. Um, and as we all know that Linux is the most popular operating system to run containers, workload, or for app development. So I would be mainly focusing on Linux here. Uh, so let's understand the current security challenges that we have with any general purpose Linux based operating system. So, as we all know, in Linux, we have namespaces, and that is how we isolate the containers. So, on my operating system, I cannot create physical boundaries. So, what the containerized architecture came up with is namespaces. Namespaces is logical boundaries that we have on my operating system, right? So, with that logical boundaries, the containers are still sharing the operating system kernel, right? And containers, they are running as root user by default. So you can gain the access, privileged access from the containers because they have default root user. And once you are inside the container, you can have the privilege access, and then you can modify the kernel, right? So that way a kernel exploitation can be done. So once somebody gets inside the kernel, it's at risk, right? uh, and then there can be denial of service attacks. One can For example, in our customer story, the port 1234 was open for everybody. So attacker can figure out that 1234 is open, and they can just bombard that particular port with traffic that can restrict the actual users from accessing the application. Also, from that port, from that entry point, attackers can get inside, and as they can have privileged access, they can monopolize resources. So I do have limits, right? When I create my containers, when I do deployments, I do put limits where I define the CPU and the memory limits. But in multiple containers, I can just monopolize all the resources, and the whole operating system can be, you know won't have any memory or CPU to facilitate my real application, right? So in that way, some attacker can get inside, monopolize the operating system, and the actual users would be denied when they will actually try to access my application. Also, in case of some application bugs, which is very less likely because in enterprises we create application with the best practices that we follow. uh, and then also the images that we are using are also highly secure. But in any case of any bug, attacker can have the access to the root of my operating system, and then there can be some breakouts, right? Also, there can be more challenges like poison images, which is very less likely because generally we do not use third party images, right? What we do is we customize the image, secure them as per our need. But in case of poison images or compromised credentials, there can be further threats. So these are some threats, and in the coming slides, we will certainly see how we can address using Bottlerocket. Now, in this section, we would be understanding about Bottlerocket. What is Bottlerocket? Uh, what are some components of Bottlerocket? How Bottlerocket is different from a general purpose operating system? And yeah, I am also sharing a few links in the chat, so please take advantages of those links as well. Also, do we have any questions till this point, or we are good to go?
Dipanshu, no questions at this point. We are good to carry forward. Just a quick note again to the attendees online. Please feel free to use the chat window and add your questions for the speaker. We'll be happy to take them online while we are going through the show. Back to you.
Yeah, thank you, Gaurav. All right, so first thing first, what is Bottlerocket? Bottlerocket, it is a purpose-built operating system that is based out of Linux. and that is only meant to run containers. It supports GPU, so if your application is demanding a GPU, we can do it using Bottlerocket. You can have a ARM 64 architecture if you wish, or you can go with standard x86 64 bits as per your application need. Also, this is open source and it can be customized, so you can customize it as per your need. Um, and It only includes the essential softwares that are required to run the containers. And for containers, we need a container runtime, right? And it can be used with ECS. So in case of ECS, it will contain the required ECS agent. But in our discussion, we are mainly focusing on EKS. And also, Bottlerocket will help to ensure the underlying software security. And as we are having less softwares, the overall maintenance overheads are also reduced. Now, talking about the component. So, if we see from a operating system architecture standpoint, a Bottlerocket is definitely, you can say, complex, but I'll try to simplify it using 4 points. So first is Bottlerocket is a minimal operating system that only comes with system softwares and container runtimes. It follows the atomic update mechanism. We will understand about atomic update mechanism in the coming slides, but just for a one-liner, atomic update mechanism follows a mechanism where we update the whole operating system with the image. It can be integrated with EKS and ECS, so the integration is supported, and that's a crucial component, I'll say. And then the admin and the control containers. We will understand about the admin and the control containers, and we will also see the admin and the control container in action in our demo. So that's the four more important components of Bottlerocket. Do we have any question, Gaurav, in the chat?
Right. So there are no questions from our viewers right now. However, I was curious. You mentioned Bottle Rocket and the benefits, and then we were talking about the components. Is this an open source operating system, or is it a proprietary solution? Can you throw some light on that, please?
Sure, sure. So it is indeed open source. Like I said, it is based out on Linux, and then it is open source. You can customize it as per your need. I would be talking
Mm-hmm.
about that in the coming slide, but as you are having a question on that, so let's clear that first. Yeah. So we have a GitHub page where you can go. You can find details that can help you to customize this. Also, if you are having some issues around customization, you can go to the Bottlerocket GitHub page. There you will have the issues section. You can go there and you can add your issue. Our service team engineers, they will definitely help you with your issues, with your questions that you are having around customization. So yes, it can be customized as per your need.
All right. Thank you.
All right, proceeding further with our next slide, which is a comparison between Bottlerocket and Linux, how Linux and Bottlerocket are two different OS. So we all know in Linux, we have, I mean, Linux is a general purpose operating system, right? And it can run a wide range of applications that are packaged with some package manager, for example, RPM package manager, or we can run containers. And that is not the case with Bottlerocket. In Bottle, excuse me, in Bottlerocket, we do not have any package manager. We have a container runtime and minimal operating system softwares. In Amazon Linux, which is an optimized operating system that provides us the ability to configure each instance as necessary for the workload that we are running using the traditional tools. For example, yum, ssh, tcp dump, netconf, etc., etc., right? That is not the case with Bottlerocket. In Bottlerocket, which is a purpose built to run containers. It will allow us to run a large number of containers. Uh, Specifically, it will differentiate from Amazon Linux in a few ways. So it does not have a package manager, like I said, and it has the required software just to run the containers. Updates in Bottlerocket is not applied in the regular or the standard way we follow for Linux. Here, the updates are applied in atomic manner, and those can be rolled back in just a single way. There are some issues with your updates, just a single click and not a click, but just a single step, and the updates would be rolled back. That's how atomic updates work. So it will reduce the scope of errors. The primary mechanism to manage Bottlerocket host is using container orchestration. For example, using Amazon EKS, right? And yeah, that's the major difference. We cannot manage Linux using EKS, right? And in the coming slides we will understand about some how we can connect and how we can troubleshoot. But just one liner, if you want to troubleshoot Linux, you can go to Linux, ssh to it, and maybe install some tool. Let's say you want to install TCP dump, so you install it and you perform the action at the OS. In Bottlerocket, you want to do some troubleshooting, you have to do it inside a container, you cannot do it on the shell. All right, talking about the benefits of Bottlerocket. So by this time, a lot of things are already cleared, but let me highlight the top three benefits of Bottlerocket. So as we know that Bottlerocket is having very minimal operating system softwares, and it is on the majorly is the container runtime that the Bottlerocket is having. So because of the lower complexity using Bottlerocket, and the overall management is higher, so you do not really have to put a lot of efforts. And also if we compare it with Linux, let's say I have T3 medium instance, okay, and I have two T3 medium instances. On one I have Amazon Linux 2, and another one I have Bottlerocket. Now in Bottlerocket, if you will see, I only have specific softwares, but in Linux there are other softwares, general purpose OS softwares also running. So those would be utilizing some CPU, some memory. That is not the case with Bottlerocket. So if we see from that way, the overall resource utilization is lower. So that is somehow adding to my cost, because I can run more containers as compared to a Linux OS with the same configuration. And then it provides us improved security. uh, Updates to Bottlerocket are applied in single atomic unit, and those can be rolled back if necessary. So it removes the risk of updates that can leave the system in unstable state. That is not the case with Linux, right? And also we know that update failures are common with general purpose operating systems because of the unrecoverable failures, right? When we do package by package updates. In Bottlerocket, the automatically applied atomic updates can be reversed in a minimal disruptive manner, and that will improve the overall security and management, right? And as we were talking about the open source and customizable OS part of Bottlerocket, so we have developed it in such a way that our partners, our customers, and all the interested parties can make changes to the code of the Bottlerocket as per their requirement, and then use as per their need. So before I move to the next section, I would like to ask if there are any questions in the chat, Gaurav.
Right.
Right.
Dipanshu, we do have one from Henda24. The question is, Bottle Rocket can only be used in cloud environments, or it can also be used in local environments for testing?
So Bottlerocket, as of now, it is available on cloud, and it is designed specifically for containers to run containers on the cloud, right? uh, like I said, that you can be use it with EKS, you can use it with ECS, but I doubt that as of now we can really use it with Kubernetes or local Kubernetes, right? So it's available on a cloud. But yeah, you can definitely go to our GitHub page, go to issues, and there you can definitely raise a request saying, showing your interest on getting Bottlerocket locally so that you can do
Hmm.
your test.
Right. So yeah, that makes sense, right? So it's tailored for Amazon cloud and then to
Yeah,
host containers in the cloud.
yeah.
So that's where it's best used. All right. That's the one question I had. Thank you.
All right. Yep. So thank you for the question, Hida. I'll move forward with our next section, which is on the security features and implementation uh, of Bottlerocket. There we will also see a small demo in later slides. Okay, so let me quickly change the slide. All right, so this is one of the interesting slide. I really enjoy this slide in my deck. So how Bottlerocket address the security concerns, right? I am saying that it is secure. So how is it secure? What are some advantages that it brings? How it will make my cluster secure, right? How the overall ecosystem would be secured using Bottlerocket. So uh, yeah, so Bottlerocket does not have any shell in interpreters and package managers. So any additional softwares that are installed in containers, right? uh, like I said, any TCP dump that would be installed in the container. There is no shell for that. And the control and the admin containers that are pre-installed, they can be used to install packages from the Amazon CM repository. Also the access to Bottlerocket, it can be regulated with IAM. So to access Bottlerocket, you need to have IAM permissions. Otherwise, you cannot access it. No matter you are trying from SSH or you are trying from console or whatever way you are doing, you need the IAM access. So the overall reduce this overall reduce the attack surface because you really do not have a lot of entry points here. Then the full system disk updates that are applied to the node is first written to an inactive partition. So let's say this is my OS disk. I want to do some update. So the update won't be written on this one. I will have additional partition that will contain my update. And then there would be a reboot. At that reboot, this is my additional secondary partition. It will be considered as the primary. If there are some issues, we'll roll back to this one. Otherwise, we'll continue with this one. So that's how the atomic update mechanism will work with alternate partitioning, right? So one interesting fact, we follow the TUF, or known as the update framework mechanism. So the update framework mechanism, it is designed to protect the update mechanism, and it will automatically identify the updates and download the updates to my OS. So we are sharing a link in the chat about TUF, about the update framework. You can refer to it to understand more. uh, Let me add a few points here. So the Bottlerocket image, it is pulled from a TUF protected repository. TUF provides a secure in-place upgrade mechanism. Each update image is embedded with a single root.json file. So you can say that it's sort of a signature file. This file, it contains a chain of trust that Bottlerocket will trust. So now you know you have someone to trust, right? You have a authority. Then the TUF repository, it will also include another signed file that is known as targets.json file. It will list all the available target files in the repository. So I am aware of the target files that are in the repository, and it will also contain the hashes. So any listed file can only be downloaded from the TUF repository, preventing downloads of untrusted data and images. So the image based updates using TUF mechanism, it's really robust, and it really reduce any loopholes during the update part. If there are some issues, the OS won't boot, it will go back to the original partition. Um, in the earlier slides, we were discussing about the elevated permissions and about kernel exploits, right? So, how Bottlerocket can lessen the severity of those security incidents, because s- y- uh, attackers will still try to attack. We cannot restrict those attacks, but what we can do, we can make a robust system. We can try to lessen the severity of those security incidents. So in Bottlerocket, we can configure kernel lockdowns in integrity mode. Integrity mode is the default mode in Bottlerocket. This will limit any attacker's ability to override the kernel's memory. That's a very important part, because if attacker gets the access, the first thing they'll try is to overwrite the memory or to modify its code. But that Bottlerocket will restrict that ability. Bottlerocket will also prevent an attacker from loading unsigned kernel modules. Only kernel modules included in Bottlerocket images can be loaded. So the kernel module has to be in the image, otherwise it cannot be loaded. That's about the integrity mode. We also have another mode that is not the default one, but we can change it, and that is known as the confidentiality mode. This mode, it will limit the way an attacker can read kernel's memory from user space. So the primary purpose of this mode is to protect secrets that are stored in the kernel. So now we are really restricting any sort of kernel lockdown the attacker can do using the integrity and the confidentiality mode. And attacker cannot really load some unsigned modules or make some changes to its code. The fourth point is read-only file system and DM variety. So let's understand what is read-only file system. So in Linux, Amazon Linux, Ubuntu, any flavor, our root file system is not read-only. We can write to the file system, right? That is not case with Bottle Rocket, right? So in case of any attack, the attacker may try replacing some files on the root file system if they are not able to do so on the kernel, right? So Bottlerocket mounts the file system as read only, so that will prevent any changes on the root file system. So suppose this is my root file system, I'm an attacker, I made some changes, the changes won't stay because it's just read only. So to make it more robust, Bottlerocket uses DM verify. Again, we are going to share a link about DM Verify in the chat. So, Bottlerocket will uses DM Verify. It is a kernel module that provides transparent integrity checks of block devices. It maintains the file system integrity by caching changes. So those changes that we are trying to do, those won't be written; those would be cached. At every boot, the DM variety will verify the integrity of the root file system, and if there are any errors, any corruption with regards to the integrity, it will refuse to boot the operating system. So this will help to, to protect some vulnerability uh, to get inside our root file system and allow any sort of attack. Also, we use ephemeral storage for configuration. So users cannot really modify the system configuration files such as /etc resolve.conf or anything mostly in the /etc folder directly. If you have to do something, then there is a way to do that. You can do it for example from Kubernetes. You want to modify something, you have to do it from your Kubernetes cluster, right? So /etc, it is mounted as a temporary file system, and changes won't persist after a reboot, same like the root file system. And like I said, that the Bottlerocket APIs can be used from the admin and the control container to make those persistent changes at the file system, or we can do it from Kubernetes. So I think that's about some security concerns. Do we have any question around this slide, Gaurav?
Right, Dipanshu. Let me first start by reminding our viewers. Please feel free to ask questions. We can
Yes.
take them online and then have Dipanshu answer them for us. No questions so far on the security side of the things. I do have one question on the billing side of it, though. So I know with Linux, a very popular feature for our customers is the per second billing. So does Bottlerocket also support the same feature?
Okay. So when we talk about the billing, the per second billing, the on demand usage, right? So
Mm-hmm,
Bottlerocket is just an operating system, right? We
mm-hmm,
are still
mm-hmm,
going to host it on EC2, right?
mm-hmm,
And the billing will be same across. So it's Linux. You are getting billed for the resources
mm-hmm,
or the instance type, and then
mm-hmm.
whatever you are using, same goes with Bottlerocket. So it's same as EC2 Linux. You are not really paying something for the image.
All right. Yeah, that's a very good feature add-on with all the security uh, tools that we have.
Yeah,
Billing remaining the same is an add-on. All right.
yeah.
Thanks, Dipanshu.
There,
Yeah,
there can be some cost differences as with respect to licenses. For example, in Windows, you pay for the Windows licensing. That is not the case here with Bottlerocket or Linux. So that is the only part that will change. But the way you are getting built, it's same as EC2 Linux, any EC2 instance.
oh, thank you.
All right, so we are hearing a lot about Bottlerocket. Bottlerocket is secure, atomic updates, etc., etc. But how do we really implement Bottlerocket? How do we really launch a Bottlerocket, right? So there are multiple ways of implementing Bottlerocket, and there are a few requirements. For example, if you are trying to do it from the command line, the best is you have the Amazon provided CLI, AWS CLI. We need a key pair because we can connect to Bottlerocket using SSH, but we have to enable the admin container that I will show in the demo. And then we also need the Amazon provided EKS CTL, that is a command line tool specifically designed for EKS. So if you are if you have spent a EKS cluster, then you know about EKS CTL. So using that, you can create a Bottlerocket node group using the YAML file, or we can create manage node groups. We can just simply go to our console. From there, we can go and create a node group. From there, you can select a Bottlerocket operating system. It will take the Bottlerocket matching your cluster version. For example, in my lab, I would be showing 1.22. So my Bottlerocket node version is also 1.22. Uh, you can also create self-managed node. You can get the image ID from our publicly available document, or you can just search on the internet Bottlerocket AMI ID, and you will get all the AMI ID specific to the region that you are going to create. For example, you want to do it in US East 1, so you need the image ID for US East 1, so on for US East 2 or any other region. And when we talk about scaling, because in my cluster, let's say my cluster is very secure. I'm using Bottlerocket, and it's secure. But what about scaling? If it cannot scale, then there is no advantage of having a secure cluster, because really it won't be able to take all the load, all the requests that are coming. So Bottlerocket can be integrated with a cluster autoscaler and Carpenter the same way we integrate any other node. For Cluster Autoscaler or Carpenter, Bottlerocket will act as any node that is already in my cluster. So in Carpenter, I can put the image ID. In Cluster Autoscaler, I can still do the same thing, and my autoscaling group would be having the image ID of my Bottlerocket node. All right, so how do we connect? Another important part, because we cannot really do SSH, like I said. So how do we connect to it? And then there is this diagram on the screen that will give you some more insights. So as you see, the Bottlerocket operating system, the whole boundary is there. Inside that, I am having my container runtimes. You can see container D and Docker D. Then you see that I have a control container which is having SSM agent pre-installed, and then I have admin container which is having a SSH server installed on it. If you see, the control container is highlighted, but if you see, the admin container is grayed out. It is grayed out because by default the admin container is disabled. Because admin container can provide SSH access, we have disabled it so that nobody can SSH to it unless we enable this, right? And then on the Docker D boundary, you can see my ECS tasks are running. You can also run EKS task here. It's just for reference. So things are isolated, right? My task, my containers, my application is isolated from the admin and the control containers. Now, how do we connect? What we are going to do is we are going to AWS console. From there, we would be taking a SSM session manager session to the control container. From the control container, we will enable the admin container. And then from there, we can SSH using the key pair. If you do not have the key pair, if you have not created a key pair, then SSH cannot be done. And the other way to access the admin container is from the control container. So you connect to AWS console, you SSH. Oh, sorry, you connect to AWS console, you took a session manager session to control container, and from there you can do admin container access. So I would be demonstrating that in my video. So here is a demonstration of how we can connect to Bottlerocket. So I am in my terminal, and let's see if I can see some nodes. So I must be having one node in my cluster. All right, so this is my node. It's Kubernetes 1.2.2 and just a single node in ready status. All right, so now let's go to the console. Okay, so this is Bottlerocket 2, my auto scaling group, and I'll go to my cluster. EKS auto scaling is my cluster. It's 1.2.2. You can see it here, active status. Here are the details. And now let's go to the instances. So this is my node, EKS node. Um, here are some details of my EKS node. Let's see the image ID. That's Bottlerocket 1.2.2 matching my cluster, and this is the built version that we are having here, and it's the AMI ID. You can get the image ID from our public website. Now I click on connect, and here I'll go to session manager and connect to it. So a new session is open here, and it is connecting me to the control container. So you can see welcome to Bottlerocket's control container here. Here are some commands and some information, and it's telling me that we can debug the system using the admin container, and to enable the admin container we can run this command, and we can enter it. We can also disable it, we can enable it. So there are the three top commands we see here, right? Now let's try to get inside the admin container, because control container is just like a gateway for my admin container. So I'm enabling the admin container, and now it is enabled, and now I need to get inside it, right? So for that, I have to enter it. So let's enter it. All right, welcome to Bottlerocket's admin container. Now this is the thing where I can troubleshoot it. You can see the user as root add admin. Earlier it was control session SSM at control, right? Now it's root add admin. So here I can perform whatever task I want. I want to do something, we can update it. Now I'll exit and I'm back to my SSM user at control. So this is my control container. And if I want to do SSH, then my admin container has to be enabled. And it's good practice that we always keep it disabled, because that way we really restrict any SSH connection. Now it is disabling the admin container, and the admin container should be stopped soon. So keeping it disabled, like I said, and then we really need to go inside the control container to enable the admin container. So I'll terminate the session, and we'll be back to our deck. All right, so now this grayed out diagram of admin container, it's I think it's surely making some sense, because why it's grayed out? It is grayed out because this is not enabled by default. So we'll move to the next slide and understand about the update part. So how to update? How to update Bottlerocket? There are three ways. We can do it using the Bottlerocket update operator. I would be sharing a link for that. Then we can do automatic manage node group updates. We can do the same for Linux, right? If you are using EKS, then you know about the manage node group updates. You just go to console, do a click, and it's done. Or we can use the update APIs that we can perform their from the admin container, right? So Bottlerocket, like I said earlier, that Bottlerocket will download a full disk image, and then it will reboot it into rather utilizing a package manager. And then Bottlerocket will download that full disk image, system image, and reboot into it. It can automatically roll back in case of any failures. That's very important part here. And workload failures can trigger manual rollbacks, right? Suppose there are some issues, but it's not rolling back, we can trigger a manual rollback. And about the update mechanisms. So Bottlerocket update operator, it is a custom Kubernetes operator that will follow the control loop Kubernetes principle. So a control loop Kubernetes principle is a non-terminating loop that can regulate the state of a system. It will check the state, and based on that it will perform the updates straight from the Kubernetes using the kubectl commands. Second, automatic updates that I already discussed. I can also use node labels to prioritize the updates. So I have multiple nodes, I can use node labels and then do it systematically. Then there are some update APIs. Those can be run from the control and the admin containers, like I said. uh, those can check if there are any new versions available. For example, API client update check, it will check if a new version is available or not. API client update apply, it will download the update, verify the update, and it will not apply it, because if you remember, update will be applied at the time of reboot, right? And then the next command is API client reboot. Rebooting will activate the new update, and my system would be up and running. In case of failures, it won't boot, it will roll back. If you want to do update rollback manually, first of all, it is automatic. It should roll back automatically. In case it's not able to detect it, then we can do a reboot by just running two commands, which is sign post rollback to inactive and then reboot. So that's about update, and that's about updating rollback. And that's also about our discussion with Bottlerocket. Now we are at the question and answer section, and I am more than happy to take all the questions. Gaurav, please let me know if we have something in the chat.
Absolutely, yeah. We have two different questions. Let me start with the first one. This is coming from Louis Wett. The question is, does Bottlerocket have SE Linux enforced? And the follow-up there is also, can I make host net/network mode privilege changes to the CRI running on Bottlerocket?
Okay, so honestly, I am not sure about the SC Linux part, but I doubt that it would be, because we have developed it based out of Linux, though SC Linux is also using the
Right,
same sort of libraries, but
right.
I'm really not sure if both will go hand in hand. And then talking about the host networking modes, so that is something I think you are talking about the Docker networking mode, like we have bridge, host, network, etc. modes, right? If that is the case, then yes, because that is happening at due to the container runtime, and I should be able to configure the network as per my need. That is purely for the container communication. But I don't have any answer for the SE Linux part. If you want a
Sure.
detailed answer on this, Luis, then I think going to our GitHub page and posting it there should be the right step, because
Absolutely.
our system team, service team, they have developed this product and they will be able to give you more details into it.
Absolutely. And just as a quick reminder, right, Bottlerocket, like any other Amazon service, adheres the shared responsibility model. So we define the security and compliance as a shared responsibility between the OS vendor and the customer's OS vendor being us. We'll definitely adhere to all the best practices. However, there are configuration items that we request you to please keep in mind. By default, while Dipanshu was talking through this, I looked it up. SEL Linux is enforced by default. So, Louis, to answer your question, it's there. Only if you choose to disable it, there is a optional flag for you to do that. You can do it using a superpowered flag, but again, adhere to the shared responsibility model while you are looking into making those changes and running your workloads. All right, thanks, Dipanshu. So the next question I have is again around the updates to the AMIs that you mentioned. In this case, specifically, the question asks, how can you update a Bottlerocket custom AMI?
Okay, so if you remember about our update part, our atomic update section, I mentioned about the that it will download the images, the whole images, right? So in case of custom images, you have to manage that part, right? Because if there is a new update available, you download it, that won't be your custom image. That is something we are providing. So in regards to custom image, we are still exploring that part. A lot of custom images are still not being built, and we haven't seen our customers really reaching out to us discussing about custom images. So Bottlerocket is in very early phases, and talking about custom image update at this point, I really think it's not a area where we have really done some sort of expertise. So I will again say reach out to our developers on the GitHub page. Do you have some
Sure.
points to add here, Gaurav?
No, that's the recommendation. Thanks again, Dipanshu, for sharing that. So feel free to ping the GitHub link with your queries. We'll get back to you. And if there are further questions, my request to the live viewers is to please put them in the comment section. We'll be happy to take them online and then try to get you some answers.
Yeah,
All right. Just one more follow-up that I had on my end. We talked about the features and the benefits of custom purpose-built Bottlerocket OS that is there, right? So
yeah,
is it also backed by the AWS support? So if I am running my production workloads on this and I have an issue, of course, I can reach out using the GitHub link, but can I also open a support case and be helped with it?
yeah, yep, certainly. So first, I'm not sure if I have discussed this, but if it's running on Linux, it should also run on Bottlerocket, unless you are making some code level changes, right? So if it's really about some configuration or some customization thing, then reaching out to us via GitHub should be the right step. But you are in production, some issue is happening, you need immediate assistance, you should always reach out to us via AWS support. The So we have to understand the AWS premium support part is when we are having some issue, right? But when we really need something with some customization help, then GitHub should serve us better.
All
So
right.
yes.
Thanks for sharing that, Dipanshu. Yeah,
Yeah,
appreciate it. Let me quickly look at the comment section. Oh, yeah, we do have one more follow up.
sure.
This question is from Zylen Drift. The question says, what do you recommend to someone curious about AWS security? So it's a generic question, not focusing on Bottlerocket, but on AWS security. So my first recommendation, even before going to Dipanshu on this, is please refer our public documentation and blogs wherever possible. If you have a specific question, you can always reach out to us using your AWS support teams by logging a case or your account representatives working with you. You can always post your questions in AWS repost. That way, if the question is good enough for us to make it a topic for one of these discussions, we'll be more than happy to do that and get it going to help you and the community going forward. Uh, and all right, looks like there is one more comment from one of our viewers here. So this is asking for a specific session. Yes, Louis, thanks for your question. The question is, can you have one session on security with EKS? And then even if it was conducted before, Louis, we'll be happy to share the link
Yeah.
with you for the previous sessions. But security on EKS is like any other security, right? It's ever evolving. So we'll be happy to keep that in mind and then try to bring it back into our mix of the episodes that we are planning. Um, okay.
So,
So with that and looking, yeah, please go ahead, Dipanshu.
sorry to interrupt you, Gaurav. I would just like to add one point here to answer both our questions. Security is a very generic term, and when we are talking about AWS cloud, there are so many services involved here. So there are a few best practices that we always follow, and then we have to go to the specific service. For example, always keep your NACL secure, always keep your security group secure. Those are some ground practices, and after that we have to go into the specific details. So EKS security itself is a very big broader area. For example, about your API server, right? You want to run the kubectl command, you want to make it secure, have a private cluster, or if you are even having a public cluster, then still restrict the connectivity. So EKS security is a broader uh, a wide area. And then we have to be today we are discussing about securing a node, and that's how we have to break it into parts and then understand it.
All right. Thanks, Dipanshu. And Louis, we have also shared a link with you. There is a separate series that you can please refer to. All right. Unfortunately, that's the entirety of the time that we had allocated today. Thank you everyone again for taking the time out and joining us for this session on EKS security using Bottlerocket. Today we found out that by including only the necessary components that are needed to run containers, how we can secure our attack footprint better and reduce it and have faster boot times and better outputs, right? So if there are any questions that were still not answered, please feel free to post them on repos.aws. This is where our experts can provide you with an answer, and it can also become a topic for one of our future shows. If you have feedback, please check the chat box for the link for our survey. You can also email us at awssupportsyou@amazon.com. We want to hear from you, so please tell us what we can do better and what else would you like to see on this show. Please join us again in 2 weeks' time, 21st December at 10 a.m. IST. We'll be discussing on how to get started with OpenTelemetry and ADOT. Again, thanks for joining AWS Supports You. Happy cloud computing.
Thank you, everyone.